morning, friends. In the last period we have started the new topic, that is electrostatics. In the electrostatics we have to discuss some concept, that is Coulomb's law. After that, electric field, electric flux, flux density. Then we have to discuss about the flux of electric field, its units and dimension and formulas of electric field we have to discuss in the last lecture. After that, we have studied about the multiple choice question on that articles. Now, today's lecture we have to discuss the very important law, that is Gauss law. Many times question may be asked on that, state and prove a Gauss law. This is very important, and state the different forms of Gauss law. Also, we have to calculate the Gauss law in external point field and differential form and integral form of Gauss law. These articles are very important for multiple choice related question, or many times a long question may be asked on that, state and prove the Gauss law. First of all, we are familiar with the Gauss law from 12th standard. We have also studied the statement of the Gauss law. According to Gauss law, we have to say that the electric flux is we have studied in the last period, that is electric flux, that is phi E is called as what? Electric flux. According to the Gauss law, electric flux phi E through any closed surface, this is a closed surface. According to the Gauss law, electric flux phi E through any closed surface is equal to algebraic sum of the algebraic sum of the charges enclosed by that surface. Means we have to say that electric flux is equals to 1 upon epsilon 0 times algebraic charge enclosed in that surface. That is phi E is equals to 1 upon epsilon 0. Epsilon 0 is called as what? Permittivity of free space times a total charge enclosed in that surface, that is considered as a charge is here we have a Q. So we have to say that phi is equals to 1 upon epsilon 0 times Q. Means according to the Gauss law, electric flux phi E through any closed surface is equal to 1 upon epsilon 0 times net charge Q enclosed by that surface. Net charge enclosed by that surface. This is the statement of a Gauss law. Electric flux phi E is equal to 1 upon epsilon 0 times total charge enclosed in that surface. According to the Gauss law, total number according to the Gauss law, we have to say that the electric flux phi E is equals to epsilon 0 times the net charge closed in that surface. The charge is considered as a Q, and epsilon 0 is called as what? Permittivity of free space. Now, in the integral form, we have to write the electric flux is nothing but what? That is surface integration of E bar dot N bar into ds. This is called as a surface integration over the surface is considered as a S, and that is equals to what? Q upon epsilon naught. And this is the one more formula that is called as a again Gauss law in terms of a integral form, and that is E bar dot n cap into ds. Here n cap is called as a unit normal vector having value is a, that is considered as a 1. So E ds is equals to what? We have to say that Q upon epsilon 0. And then also we have to say that the surface integration represent the surface integration taken over the closed surface. N bar is called as a unit normal to that surface, and ds is called as a surface area. Now how this law can be proved here? That is, we have to consider the proof here. In the proof, we have to say that let us consider a Q be the point charge which is enclosed at a point, say O, R be the distance, and here ds is considered as a surface area. D omega is called as solid angle. E bar is the electric field intensity, and n bar is the normal, unit normal, making an angle is say theta. So according to the definition of what we have to say that is electric field vector E bar making an angle theta with a normal drawn to the free surface of element ds by definition of electric flux. By definition of electric flux. What is the definition of electric flux? d phi is equals to E bar dot ds bar. E bar dot ds bar. What is the dot product of A dot B? We have to consider that it is a cos theta, and then we have to say that the electric flux is considered as d phi E is equals to what? E ds cos of theta. But here E is called as what? Electric field intensity. This is equation number say 1. But electric field intensity E is equals to 1 upon 4 pi epsilon naught into Q by R square. This is the expression for electric field intensity. Finally, we have to get the from equation 1, we have to from 1 and 2. एक आणि दोन वरून आपण म्हणू शकतो that is d phi E is equals to, we have to write that Q upon 4 pi epsilon naught into what we have to say that is ds cos of theta divided by r square, and here we have to substitute this value here. It gives that ds cos theta upon r square is nothing but the solid angle. So we have to write that is but ds cos of theta upon r square is nothing but d omega, and then we have to write that is d phi E. We have to integrate this equation, and after that we have to get that angle that is subtended, solid angle subtended by the surface is considered as say what we have to say that ds. And finally we have to write the equation for a d phi E. D phi E is equals to what we have to get that Q upon 4 pi epsilon naught into d omega. Integrating, it gets that integration of d phi E is equals to Q upon 4 pi epsilon naught into integration of say d omega. D phi is nothing but say phi E, and integration of d omega is what we have to say that Q upon 4 pi epsilon naught into, this is what we have to say that 4 pi, and solid angle having integration is say 4 pi. 4 pi is cancelled with the 4 pi, so we have to get that phi is equals to 1 upon epsilon 0 times a net charge, that is say denoted by say Q, and this is the statement of a Gauss law, proof of Gauss law. Q consists of a algebraic charges includes in that surface, that is nothing but Q1, Q2, Q3 dot dot. Qn be the point charges close by the surface, and total electric flux over the flux is considered as a phi. Surface is equal to sum of the electric charges due to the individual, and after that we have to write the vector form, integrand form, and or it is can be written as integration of E bar dot n cap or n bar into ds is equals to what we have to say that Q upon epsilon naught, and then also we have to write that for an external point. जब पॉइंट बाहर होगा तब क्या होगा, that is we have to write that is surface integration of over the surface S E bar dot n cap or n bar into ds, that is nothing but what we have to say that E ds cos of theta, and that is we have to consider the 0. This is nothing but for external point U bar dot n cap into ds is nothing but 0. This is what we have ds. This is the integral and form of the Gauss law. After that we are going to discuss about the differential form of Gauss law. Differential form of the Gauss law we are going to discuss in this lecture. That is, we have to consider that a charge q is uniformly distributed over the entire volume enclosed by the surface S. If rho be the volume charge density, if rho be the volume charge density, that is charge per unit volume, dq, or what we have to say as say q upon dv. So we have to write that q is equals to rho into dv. This is the volume charge density, and we have total charge enclosed in that surface is considered as say, we have to write that this is nothing but dq. Therefore, integration of dq is equal to integration of say rho into dv over the volume is say v. This is the volume charge density we have to consider for the net charge q. Then by the Gauss law is nothing but we have to say that surface integration of U bar dot n cap into ds is equals to volume integration of rho is nothing but what we have to say that say q upon epsilon naught, and this can be written as that is surface integration of U bar dot n bar into ds. What is the value of q here? This is q is nothing but 1 upon epsilon naught times volume integration of rho into dv. This is what we have to say that surface integration and volume integration equation number 7 by Gauss divergence theorem. By Gauss divergence theorem, what we have to say that surface integration of U bar dot n cap into ds is equals to volume integration of divergence of U bar into dv. This is equation number say 2. From 1 and 2, what you have to write that is volume integration of divergence of U bar into dv is equals to 1 upon epsilon times volume integration of rho into dv. Now volume integration on the both side it can be vanished, therefore it gets that divergence of U bar is equals to rho upon epsilon 0, and this is differential form, or this can be written as divergence of E is equals to rho upon epsilon 0. This is the divergence of differential form of the Gauss law we have to consider here. Differential form of the Gauss law. Many times we have to write the multiple choice question, may ask on that. That is, give the statement of Gauss law, that is basic statement, we have to say that electric flux phi is equals to 1 upon epsilon 0 times charge enclosed in that surface. Secondly, surface integration of E bar dot n bar into ds is equals to q upon epsilon 0. And the last statement, we have to say that for external point, E bar dot n bar into ds is equals to 0. And differential form, that is divergence of E is equals to rho upon epsilon 0. These are the different forms of the Gauss law we have to discuss in this lecture. This is very important. Write down all the points. Thank you.